Hi everyone, my name is Gaetano Smith. I'm with Subgroup 1, consisting of Gaetano Smith, Andy Pham, and Rajeev Atla. And today we're going to be talking about our order management system for the Pickup Plus project. So right here I have a diagram on my doc that I created that shows the SQL database that we're using. So this is the database I coded and programmed for us for MySQL. And we have users, restaurants, menu items, carts, cart items, and then finally orders. So a user consists of all the normal information you'd expect. A restaurant, similar. Menu items are items on the menu. They contain an ID, they're linked to the restaurant, they have a name, a description, and a price. We also have our carts, which are really just like a small table that essentially link together cart items and a user for when they create an order. We have our cart items, which are items that are placed in the cart. Every cart item consists of a bunch of menu items that are put into this database. Finally, when a user wants to order, they'll be able to combine their cart and their user into an order. And that order is created using all that information. So now I'm going to jump over to our code. So this is our README, and this is our code. And I will just show you our functions that we have working for manipulating this database and working with it, and we can show our workflow. I'm going to go into our MySQL workbench. This is our SQL code that consists of all our tables and all of how they relate. And here we have our insert code. So all this stuff can be added with functions using our other group's contributions, but for testing purposes, we're just going to be focusing on the order management for this part of the video. So we have our first user, Jane Doe. She's been here a long time because she's our number one. She's our first one. We have our first restaurant, the Pizza Palace, and they have two items. They're a fairly small restaurant. They have a margarita pizza and a spaghetti carbonara. So what we're going to do is we're going to have Jane create a cart and add to that cart one margarita pizza and two spaghetti carbonara. So now, when we run this, that's what our database looks like. And we can go into MySQL, and we can start our server. So if we run our server, we will be able to access it through Postman. Now, using our server and this HTTP post command, we're going to be able to create our very first order using cart ID number 1 and user ID number 1. So this order has been created successfully. It returns the ID number. And let's say we want to check the status. The user refreshes and they want to see what's going on with their order. So if we switch to get and we switch to orders / the ID, which is 1, we'll be able to send this request and we'll be able to retrieve the status of the order. So now we can see that it's pending, and you know what? We decide we no longer want this order, so we want to delete it. So we switch to the delete request, we send that, and bam, our order is officially canceled. But we decide we want to have a new one. So we go back to post, we can create a new order. So we create a new order. We have order number 2, which has been successfully created. Now, let's say the restaurant accepts our order and they start making it. Using this command, note, they can send a put request to update the order of the status of our order. So they can send this and they will successfully update the status of our order. So if we go back to our get command, we will be able to see that the status of our order has officially changed from pending to in progress. And now, if we try to delete this order, it won't let us because they're already making the order. It would be unfair to the business for an order that's already being made to be deleted. That would lead to lost profit margins and no one would use Pickup Plus. So they can't delete this order and it has to go all the way to the final stage of status updates. So if we go back to put, go back to notifications, we can send 2 more status updates. So we can check the last one, then go to get, we get 2. We can see the order is ready, and then finally, once the order's been picked up, it will stop and it will be put at completed. And now if you notice, if we try to send another one after completed, it says the order is already completed, and we can go back and we can grab the order's status and we can see just exactly that our order is completed and it will be saved in our database in case the user needs to look at their order history one day or any number of reasons.
Hi, this is the presentation for Subgroup 2, consisting of me, Christopher Saw, Parshva Mehta, and Abhiram Vemuri. We decided to split up the work 3 ways evenly, with Parshva working on the server and function handling, me working on this video as well as helping out with the function handling, and Abhiram working on the use case diagram you see here, as well as combining and editing all the videos into one. To get started, we start at the customer level, and that consists of 5 different functions, starting with add item, open menu, search item, list item categories, and delete item. As for delete item, that should only be executed once add item is used at least once. And after all that is done, it all narrows down to menu API. From there, the Stripe API should notify the user whether the payment was successful or not. As for the workbench, it should be the same as the other team members. Moving on to the actual code, here's the code as shown. This being the open menu function, the add item function, the delete item function, the search item function, list item categories function, creating the server, and different handling requests right here. As for the test cases, we will be using Postman. Okay. Here, the function for list categories lists out that the only category we have is Italian food. As for opening up the menu, we should have the 2 items, margherita pizza and spaghetti carbonara, as you see here. As for the get item function, kind of like searching for the item, we can do either ID 1 or 2. 1 should return the margherita pizza, and 2 should return the spaghetti carbonara. And that lines up with the menu we have here. As for adding an item to the cart, we will be using the add item function. We will be adding Chris's new pizza, so we send this, it gets added. Now when we update this, it should go through. Yep, with item ID 5. Now if we want to get rid of that, we can just put in the same ID. Okay, it says item deleted. Now it should update and get rid of Chris's new pizza, as you can see. And that's all.
This is Aidan Malixi of Subgroup 3, consisting of Mohnish, Patel, Michael Walters, and Aidan Malixi. I made this illustration to demonstrate what the video is going to showcase today, which is the restaurant aspect of our app, Pickup Plus. It has the 4 major functions of registering the restaurant, logging in to the restaurant, editing the restaurant's details, and deleting the restaurant. The illustration shows how we go from Postman to send requests to the JavaScript server, which verifies its details on the SQL database, whether it's registration details, the restaurant's ID, or just basic restaurant details. It verifies that, sends it back to the JavaScript server, which sends us a message that it was a success or a failure on Postman. And this works for all 4 functions, which I'll show you in a bit. But I want to first review the SQL database, which this is for our app overall, which it has our aspects such as the user, the restaurant, menu item, card, orders. But today we're just focusing on the values for the restaurant, such as the ID, name, address, email, phone number, category, and password, which is important when we're verifying information or creating an account, logging in. For our code, like I said, for our JavaScript server, we have the 4 major functions of registering the restaurant, logging in, adding the information within the restaurant, and deleting it. To show that this should work, we first start up the server. management. After we run the server, it will start on port 302. On Postman, to send requests, we're first going to establish a restaurant, make sure it's on port 302. So make sure it's on JSON, got the URL. After we send the request, it will show us that we did register it successfully, and it gives us a restaurant ID. So we use that ID. Let's say we want to log into the restaurant. We have to switch it to the ID. Make sure, since we already established that our password is going to be secure password, we're going to log in using secure password. And it should give us our restaurant details after we log in, which it does successfully. Let's say we were trying to edit the restaurant's details. We're going to do 9 because that's a restaurant ID. Make sure it's JSON. And for our body, we would, let's say we wanted to have a name of, let's say, update the name. And then let's say we want to update the address of, let's say, 456 Marset Street. I forgot the column. We'll send that, and it should tell us that beyond output. It should tell us that it updated successfully. And let's say we want to delete the restaurant. We just switch it to delete. It's going to be on ID, and we send the request. The rest, it should give us a confirmation that we have deleted the restaurant successfully. So overall, it gives us the 4 major functions of our restaurant through our server, SQL database, and Postman.
Hello, this is Group 4, Subgroup 4 for our Demo 1 presentation. We were in charge of the database infrastructure. The reason we were in charge of this is because we saw the problem that was having a bunch of local SQL databases that were not synced up with one another. For example, if one group has some information in theirs and then another group needs to query that information, there's no way to do so. While this is possible to use in the development cycle, if we ever were to push to production, we would need something more centralized. That's where we came in. We went with the AWS route and used AWS RDS systems to host our database. We are using MySQL, and while I can't get into too much detail as to a lot of this information, for security reasons, we can show a quick demonstration of it. I'll pass it on to one of my peers.
Yes, so right here, this is the MySQL workbench, which is available for all the developers on our team to access this database. And I would like to quickly point out that we have set up the database with different authentication users and different levelings of privileges. So, for example, this user 1 only has privileges to a set number of commands compared to what admin can do. Now, to go back to this query, quickly demonstrate that we can connect to this database by executing this query. Everything has been executed, and all this query does is insert some data into a table. And for the final bit of the demonstration, we'll go to a bit of code. Running this code shows that it actually can query from the database. That is it for this demonstration.